Hello and welcome to this OpenSim Creator tutorial video. I'm Adam, a developer on the project. In this tutorial video, we're going to be working through tutorial number 2 in the official documentation. You can find the documentation inside OpenSim Creator by clicking this link on the splash screen. If you click it, it'll open a browser, and the one we're going through here is number 2, which is making a bouncing block. The content in this video will pretty much mirror what's in this written tutorial, so if you find I'm going too slowly or too quickly, please consult this written documentation. Okay, so let's start. In order to start this off, let me just check my written notes on my laptop here. We're going to create a new model, and the first thing we're gonna do, quickly looking back at this documentation, is we're going to create the foot body. And just as an overview for the whole tutorial, actually, we're going to create the foot body, then we're going to create this collidable floor surface, make sure it can collide with a foot. Then we're going to add these other bodies here, any decorations, and then we're going to deal with any forces and constraints we need to add to the model. So let's get started. So the first step is to add the foot body. To do that, I'm going to click down here in the Add Body button. If you can't see this menu, make sure that you have the Actions window enabled, which should show this menu here. And click Add Body. And I'm going to add a body called Foot with mass of 1 kilo, which is the default. And I'm going to attach it to ground with a free joint. And that joint is going to be called Foot to Ground. And the body is going to be decorated with a sphere. And that's going to add the sphere into the scene. What I'm going to do is make it red. So if you click the sphere, you see there's an appearance property. And if you click this little color box here, it'll bring up a color panel. And if you just drag it to the top right there, you'll end up with a solid red color. Okay, so the next step is to raise this foot above the ground. The way we're going to do it in this tutorial is we're going to modify the TY coordinates of the free joint we've just added. In tutorial 1, I think what we did is modify the offset of an offset frame. Here, because we have a free joint for our foot body, we can instead just modify the coordinate of that joint to just offset this foot in space. The advantage of this is that coordinates are modifiable by users, so they can play with these sliders here in both OpenSim Creator and OpenSim GUI. So sometimes there's an advantage to modifying the kind of layout of your model using coordinates because it gives users a bit more freedom later down the line. So to follow the tutorial here, what you do is you select the foot to ground joint we've just added. You go to the TY coordinate of that joint, and you change the default value to 0.5. This is going to raise it up by 0.5 in Y, and by setting the default value here, it means that anyone who loads the osim file you're creating, it will automatically just put it at 0.5 when they first load the file. Okay, so we now have a foot that's floating in space. And that's the end of section 2.2 in the tutorial. So moving on to section 2.3, what we'd like to do here is add a contact floor into the model. The reason why is that if I simulate this now, you'll see that this body just falls straight through the checkered floor. The reason why is because this checkered floor in the background here, this isn't a physical floor, this is a decorative floor, and it doesn't have any collidable properties. It's just there to make it easier to see the scene and to see where the kind of 0 in Y is of the scene, nothing more. So what we need to do when we're building a model where we want to have collision, we have to explicitly add collision geometry. And what we want is a kind of floor plane. The way we do that is we go down here and we click Add Contact Geometry, and we're going to add a contact half space. And we're going to give it a name of floor underscore contact. And the thing to keep in mind with this one is that you want to reorient it. And this is in radians. We want to flip it in Z by minus 1.5707 radians. This is an example of something that should probably be converted to degrees in later versions. And we want to get that geometry, attach it to ground, and if we add it, we end up with our floor. The reason we rotated it, by the way, is just because if you the default kind of orientation, if I set all these orientation values to 0, would have been something like this, which isn't what we want. Okay, so we've added a floor. Again, if we simulate this, it's going to fall straight through. The reason why is because although we have a nice red sphere here, this sphere isn't contact geometry either. This is just a decorative red sphere we've attached to the body. So the next thing we need to do is we need to add a contact sphere. That's essentially the same as this body, like this decorative sphere we have in our model. And the way that we do that is we go down here, contact geometry, contact sphere. We're going to create a contact sphere called foot contact. It's going to be attached to foot, and it's going to have a radius of 0.1, which is the radius of the sphere we've just added. Now, we just added that. It doesn't look like it's done anything. We can't see anything. That's probably because this foot red decorative geometry is the same size. The way to test that everything is okay is if you go to your hierarchy and you go to the foot body. If you go down, you can see the foot geometry sphere here, the red sphere we've added. You could temporarily, in the properties editor down here, untick is visible. And if you toggle that a bit, you can see that, oh, okay, like there's this blue sphere on the inside, that's your contact sphere. And then if you turn it on, you can see that it's, yeah, this is clearly the decorative sphere. And the decorative sphere, actually, if you look at the properties, has a radius of 0.1, which just so happens to be the same as the contact sphere. Another thing you could do is make, the decorative sphere slightly smaller if you wanted, if that was in any way helpful. But I'm going to keep it the same radius for now. So if I just hit undo, okay. Okay, it looks like because they're the same size, actually, it just depends on rendering order. So actually what I'm going to do is make the decorative sphere ever so slightly bigger than the contact sphere. Just a little bit bigger though. Is that going to be helpful? I have to tick is visible. That was a problem, my bad. Okay, so we have our contact floor, we have our contact sphere attached to the foot. If we simulate this now, you might expect it to start colliding, but it doesn't. It still keeps falling through, despite there being collision geometry on both ends of the kind of collision. The reason for this now is that in OpenSim, you have to specify what forces occur when collision occurs. You have to explicitly add a force into your model that describes kind of your collision forces. And the reason for this is because OpenSim doesn't know what type of collision you want in terms of stiffness and dissipation. So you have to explicitly state what that will be. So to do that, what you do is you go down here and you click on Add Force or Muscle. And you go to Hunt Crossley Force, which is one that a lot of models tend to use. And let me just have a look at the notes over here. Yeah, we just add a force with default kind of settings. And if you click Add there, this Hunt Crossley force we've just added is describing what forces occur when collision occurs. But the force needs to be told what contact geometry is going to be contributing to this force for its calculations. So if you click on the force and you go to Edit Properties, there's an Add Contact Geometry button. If you click that, then you can add the floor. And if you click it again, you can add the foot. And now what you've done is you've said there's this force here with these stiffness and dissipation values that will happen whenever these two contact surfaces come into contact. So now if you simulate it, you can see that, okay, like the ball bounces and it stops, which is exactly what you'd expect. Now in terms of how much it bounces and so on, that's really dictated by the Hunt Crossley force. So if at some point you want it to bounce a bit more, maybe you turn down dissipation, for example. If I turn it all the way down to 0, for example, you can see that basically no force is dissipated as it bounces. And that's how you edit that. For this model, I'm just gonna leave it at default 0.5 dissipation. So I've just hit undo there on my keyboard. And yeah, so now I guess that's the first step of this model. We have a body that's bouncing on a floor. There's some forces being exerted whenever it bounces. Okay, so next thing to do is to build the rest of the model. This is section 2.4 in the tutorial. So what we're going to do is we're going to add a knee body. And then we're going to add a top body. These are, again, we're going to add these two things here from the tutorial documentations. And yeah, let's just do that. So first thing I'm going to do is add the knee. So to do that, I'm going to click down here, add a body, and the body is going to be called knee. It's going to be a 1 kilo mass. It's going to be attached to the foot with a pin joint. And the pin joint is going to be called foot to knee. It's going to have, what type of geometry does it have? It has a sphere geometry. Okay, and if we add that, it's going to add it. It's co-located with the first body we've added, so it kind of just perfectly overlaps with it. So to get around that, what we do is we go up to the hierarchy view here. We find the joint we've just added, which is foot to knee. And then we go to the foot offset to add an offset between the foot at the bottom and the knee. So looking at the documentation here, it's 0.5. So if I go down in the properties editor here, I go to the translation property and I type 0.5. I can move my body up like this. Now you can see, okay, well, this sphere is white, so I'm also going to go to click on the sphere here, go to appearance, make it red. And now what we have is two bodies attached to each other, where one of these bodies has a pin joint on it. Okay, and the next step is to add the third body, which is the head of the model. This is the cube at the top. So the way to do that is, again, I click on the add body, head, and this head's going to be attached to the knee with a pin joint, and that joint's going to be called knee to head. I'm very literal when it comes to naming. And I'm going to attach a brick geometry to it, and that should be everything we need. And now we've put a brick. Again, it's co-located with the body we've attached it to. So again, we go to a joint, knee to head, and we change the knee offset because we want an offset between the knee and the head, right? And we set that to 0.5. And that's our top head body. We want this to be red too, so we click on that cube, drag it all the way up, and now we have a nice red color. Okay, and that's all. This is all the three bodies added now. So that's step one. The next thing we want to do, a lot like with a pendulum tutorial, is add struts between these things, just decorative struts, so it looks a bit more realistic. And the way that we do that is we first select the foot body, which is at the bottom here, and we're going to add the strut between the foot and the knee. So after selecting the foot in the hierarchy viewer, you can then click add offset frame to add a new offset frame to the foot. And then if you say that it translates 0.25 in Y, it'll put an offset frame between them. And with the offset frame selected, if you click on add geometry, you can then add a brick geometry, which adds a cube between them, just a decoration. And then if you click that cube, you can go to half lengths property of the cube and turn it into, looking at the notes here, 0.025 in X, 0.25 in Y, and 0.025 in Z. And it adds this little strut here. And then we probably want a strut between this knee and the head, and it's a very similar process. This time we're going to right click on knee, add an offset frame to the knee. With the offset frame selected, but turn its translation properties to 0.25 in Y to put it between the knee and the head. With that selected, with the offset frame still selected, we click on add geometry, brick, and we set this brick's half lengths property to 0.025, 0.25, 0.025. And these magic numbers are just from eyeballing and having a feel for what kind of skin we would like to have this model to have and how we'd like these structures to look. They don't physically do anything for the model. Okay, so now that we've done that, you can see that we have our three bodies for all kind of attached to each other with joints, and we've added some nice decorative geometry. So this is our whole mechanism. But the problem you'll find is that if you start simulating this model, is that, oh, that's a problem. If you start simulating this model, it goes through the floor. Have I disabled a force at some point? I didn't. I must have hit undo too many times. Let me just quickly re-add the foot contact to that force again. Sorry, guys. I must hit undo. Okay, so now this is okay. This is just a little mistake for. If I simulate that, you can see that what happens is that it drops, it hits the floor, but it hits the floor very vertically on, right? And then it kind of stays there, and probably over time, maybe one angle kind of wins out, and eventually it starts rolling around. Okay. So to make this a little bit more interesting, what we're going to do is initially kind of give the model a more interesting layout. We're gonna have like a kind of kink in the knee, and the way that we do that is that we first what we're gonna do is angle the whole model by finding the let me just resort these coordinates not alphabetically, so they're by addition order. We're first going to find the RZ coordinate, and what you can do here is if you mouse over the coordinate in the coordinate editor, you find RZ, and what you want is one that's owned by foot to ground, which is the free joint. And we're going to change the default value of that. So if you right click it, it'll select it. And you can go down here to the properties editor. This is a properties editor for the coordinate we've just right clicked. We're going to change that default value to 0.698 radians. That's going to rotate the whole model like this. And then we're going to find a foot to knee pin joint. So we need to find the RZ foot to knee here. Right. Another way of finding these coordinates, by the way, is that you can just go to the hierarchy and then find foot to knee. This is the foot to knee joint, and then find the coordinate, which is a child of that. Either way works. They both do the same thing. So just pick a favorite. And what we're going to do is set the default value of that one to -1.396. Let's give it this angle here. And now you can see that the model is kind of in the arrangement that the tutorial documentation shows. So now what we find is if you simulate it, okay, it falls, but it at least immediately starts rolling around rather than kind of like try to figure out what the angle it should be is. Let me just find that previous simulation there. So just a slightly more interesting starting arrangement. Okay. So that brings us to the end of 2.4. We're now doing section 2.5 in a tutorial. So we have our model, but you see what happens is it just kind of hits the floor and just flops into itself, right? So again, looking at the simulation, you can see that it just hits the floor and just flops along. So to make things a little bit more interesting, what we can do is we can add a spring between the foot here and the head. This is just purely to make the model a bit more interesting. I mean, obviously, if that isn't what you're modeling, you wouldn't add something like this. But just for this particular model, it's what we're going to do. And what we want to do is add just a spring between here and here. And the way that we do it is we go to add force, point-to-point spring, and we want a point-to-point spring that's called, looking through the notes here, foot to head spring. And it has a stiffness of 2000. We're going to play with this in a bit. Doesn't need to be any number in particular, and it has a rest length of 0.8. And we want it to be between foot and head. If we add that, we now have a spring between these two, so that if we now simulate it, you can see that at least it kind of bounces a little bit before it starts rolling off. And we can edit the spring. So if you click on the spring, you can, of course, change the stiffness and change the rest length to get slightly different behaviors. That's how you'd experiment with this layout. Okay, so yeah, so we now have our model with its spring. But you can see that there's a bit of a problem here. Like if the model hits the floor, it bounces a little bit, and then it starts rolling around like this. And if you imagine what we're trying to do here, maybe what we're trying to do is create a nice bouncing kind of mechanism, and we're not trying to really spend our time balancing this model. Trying to get this model balanced would be very, very difficult. So what we're going to do next is we're going to add some constraints. And the reason we're going to add these constraints is because what I'm interested in is figuring out what spring would work for this type of mechanism. And maybe I can pretend I'm dropping it down a tube or something, so I'm not as bothered about this backward rolling motion here. So what we can do is we can constrain it to always be along one axis. And when you're building a model, that's very important. Constraints let you simplify parts of your model building process by saying, like, okay, this axis doesn't matter as much for my model. And yeah, that's what we're going to do here. So to do that, what I'm going to do is I'm going to go down to add constraint. And the constraint I want for this one is a point on line constraint. There's an explanation down here, but effectively what it's going to do is constrain one of the bodies to be along a line. So first one here is foot y, y block. And it's going to have a line direction of +1 and y, so just imagine a vector pointing up and y. And the line is going to go from foot to ground. And we're adding this constraint just did. You can see it in a hierarchy up here. Constraint set, the foot y lock. What this constraint is doing is it's just making sure that this foot is always constrained to be just along this y. It's not allowed to roll left or right. So if we now simulate it here, you can see that the rest of the model rolls around and starts swinging, but the foot just hits the floor straight on, and it's always constrained to be there. Okay, but obviously that swinging isn't great, so the second constraint we add is to the head to stop that from swinging around. So head y block. And the head, much like the foot, is going to have a direction of +1 and y, except this time we're going to select the head, and the head has to follow along y in ground. Okay, and that means that this head has to always just be along a straight line coming from ground. And if you simulate this, you can see that the model drops, it starts bouncing, but it doesn't roll. And the reason it doesn't roll is because this thing has been constrained to stop it moving to a different kind of value here, right? It's been this constrained to a line just going down the middle of the model. Now, the advantage of this is that now we can start modifying the weights of these bodies and modifying the properties of these springs without having to constantly deal with rebalancing the model, which might be significant for your particular modeling needs, right? You might not care so much about balancing it. You might be interested in just what spring parameters work best. So now I could, for example, click the spring and just say, okay, the stiffness is a bit lower. Maybe we can try a slightly different resting length, and then we can simulate that and see what would actually happen, how that would look. And that's the value of adding constraints into a model. There's a huge blurb in the tutorial documentation explaining the rationale behind this, but it's very common when making a complicated OpenSim model to use a couple of constraints to simplify the model building process. Okay, so that's it all built. We have our three bodies, we have our two pin joints, we have our spring, our constraints. It hits the floor. It is has a collision with the floor. Now that we have our model built, of course we can save it, right? So we can now say bouncing block, and we should be able to open this in the OpenSim proper user interface. So if we go in here and bouncing block, you can see that, okay, we can open this in OpenSim, and we can of course simulate it. And we can see from the simulation footage, it all does the same thing. So now you have access to multiple tooling. And yeah, the thing I'd recommend to try is maybe try a few different spring parameters, try a few different mass parameters to see how this model reacts. But yeah, hopefully this has been a useful tutorial for learning how to build a slightly more advanced OpenSim model. And what we're going to do next in tutorial 3 is switch a little bit. We're going to start using what's called a mesh importer to pull in much more complicated mesh files to build potentially more complicated models in the future. But the techniques that you use in these earlier tutorials 1 and 2, are pointing out the things you can do with what I guess you could call raw OpenSim. Types of components you can add for forces, contact geometry, and so on. And yeah, hopefully this has been useful, and I look forward to seeing you in the next video. Goodbye.